And the key here is, first of all, we need to just remember what is an exponential equation. What do you think it is? First of all, what does an equation have to have?
Principal. An exponent.
That's going to be the second part. Just a basic equation has what in it?
Y.
Y equals
An equal sign. An equation has an equal sign. An exponential equation will have a variable where? As an exponent. Okay? So those two things go together. Equations, so equal signs, has an equal sign. In equations in which variables occur as exponents.
So would that be like x to the second and stuff like that?
It would be like 2 to the x.
So then what do we do that? I understand.
Oh, well, I'm going to tell you what you're going to do.
You want to take these notes?
No. We talked about exponential, what is an exponential equation, but we didn't talk about how to solve when we have exponential equations. Okay, so here's the key. If two powers are set equal to one another, and they have the same base, for example, 2 to the x is equal to 2 to the 5th. Okay, notice how we have an equal sign. That means it's an equation.
It's an equality, right?
It's an equation or equality, sure. Yeah. Okay, because there's an equal sign. And notice how we have two powers, right? There's powers on each side because each of them has a base and an exponent. You with me so far? Notice that the bases are the same. What's the base on both sides? 2. Okay, so we're going to start there. If you have two powers that are set equal to one another and they have the same base, their exponents are also equal. So this is the key takeaway from this section. If the bases are the same, the exponents are equal. And that is how we solve. We can figure out what x equals. Because the bases are the same, that means the exponents are equal to one another. So do you see how we did that? Okay. To solve for x, we would just then, because our bases are equal, we would set the exponents equal to one another and find that x equals 5. But this is the key. The bases have to be the same in order for you to solve. Okay? So all of our exponent rules and stuff are going to start coming back into play. Here we go. Example 1. Solve. Not quite. Okay. So notice, we've got an exponential equation, right? We've got two powers that equal to one another. Their bases are the same. So what do we do with the exponents? We set them equal to one another. The bases are the same. So we can set the exponents equal to one another. X plus 1 equals 5.
4.
And now we can solve. Yep, solve for x. Subtract 1 on both sides. X equals 4. Okay?
So what happens when you don't have the same base?
That's the crux. That's when things get sticky. I'll show you. Yes.
So
Do we have the same base of our powers?
yes.
Yes, it's both 6. How are we going to set up our equation to solve?
Put the 1 on the 6.
Yes. Don't forget that there's an imaginary 1 out here. Okay, and then now we can set up an equation that 1 equals 2x minus 3. And now let's just use our rules of equations to solve for x. Start by adding 3 to both sides. And then divide both sides by 2. X equals what?
2.
Good. X equals 2.
But what happens when
Solve it in your
you don't
notes.
have same bases?
I'm going to show you that. But I want to make sure we're really good at doing it with the same basis. So try this one in your notes. Okay?
Then 30 equals. Wait, no, 100. It's to the power of.
Yeah. So x equals 3. If we're solving for that x equals 3. All right, here we go. The question on everyone's mind. If you have an exponential equation where the bases are not the same.
Divide by 3. Actually, that would work.
For example, so this is our example. We're going to do this one for our example. Notice how the bases are not the same here. We have 9 to the x, and we have 3 to the x plus 2. So at this point, we can't just set the exponents equal to one another because the bases aren't the same. What we have to do is rewrite to get the same bases. Could you rewrite 9 as a power that has a base of 3?
Huh?
Could you rewrite 9 as a power?
No. Sure.
What's
How
9?
would you do that, though?
How could I rewrite 9 with an exponent base?
3 to the third.
3 to the...
First. Second.
What's 3 squared?
I'm so
Nine.
slow. Gosh darn it.
9
to the second.
Yeah.
That's 9.
Yeah, 3 squared is 9. So could I rewrite 9? I don't know if I did this. As 3 squared. Oh my gosh. Okay. Do you see how we did that?
Yeah.
Is 9 the same thing as 3 squared? Yes. Now do I have a base of 3? Yes. Okay, and remember my exponent rules. Power of a power. We would multiply 2 times x. So we end up with 3 to the 2x equals 3 to the x plus 2. And now what can I do? Now I've got the same base. I can set my exponents equal to one another. And I can solve. Okay, so subtract x, x equals 2. Try this one. Now,
I got it.
this one's easy to do in your head if you know your perfect squares and cubes. What's x equal?
3.
Yeah. We know that 5 cubed is 125. But the way that we could do this is we could also write 125 as 5 cubed. And say, well, 5x equals, if we rewrote 125 as a power with a base of 5. And then we can set our exponents equal to one another. X equals 3. Try this one. Not super difficult. We're always looking, how can I get my bases to be the same? Which one are we going to rewrite?
4.
The 4. How can I rewrite 4? As 2 squared to the x. And then my other side I can just leave because it's already got that base of 2. What do I do with these exponents? Power of a power. What should I do with those exponents?
Multiply.
Multiply them. So I get 2 to the 2x equals 2 to the x minus 3. Now I have the same base. I can set my exponents equal to one another. And then I can solve for x. 2x equals x minus 3. Yep. X equals negative 3. About this, are we going to be able to get these both to a base of 9?
Yes. Because how do you get 27 divided by 3 is 9? Or 9 by 3?
It's not dividing by 3. We got to write it as a power.
It's 9 to the power.
Square root.
And then you do
A square.
Okay, you guys, we can rewrite these both with a base of what? 3. A base of 3. Because 9 could be rewritten as 3 squared to the x plus 2. And 27 can be written as what?
3 to the 3rd.
3 cubed, or 3 to the 3rd. to the x. Okay, from here, now we've got to simplify this properly. We're going to multiply, because it's power of powers, and basically distribute that 2 to both terms in our exponent. 3 to the 2x plus 4 is equal to 3 to the 3x. Okay, when we get to here, set them equal to one another because we have the same base. And then we can solve. 2x plus 4 equals 3x. Yes, subtract 2x. And 4 is x. This is where rules of exponents, I mean, we already saw it kind of in the other two, but rules of exponents continue to come back in this lesson. So negative exponents, how we deal with negative exponents, that's going to be part of all this. So look at this. Okay, 1 over 2 to the x equals 4.
You gotta put the little 1 thingy on 4.
Okay, maybe.
Okay.
See, 2 to the 2 squared has a number that's in that fraction.
Okay, yeah, okay, yes. Let's go with that first. Could we rewrite 4 as 2 squared? Because we see that this is going to be something that's going to be important.
Yeah.
How could we rewrite 1 over 2? What if we bring that 2 up?
Oh, 2 over 1. So 2 would just be 2.
2 to the?
First, second,
X.
third, fourth, fifth, sixth.
Stop. What if we bring the 2 above the fraction bar? What happens to it?
Oh, get to.
Ava, get off of that iPad. And distracted.
Okay,
Remember, when we bring a number across the fraction bar, what happens to its exponent? It becomes negative. So let's bring this 2. What's the exponent of 2 where it is now? Right. Technically, there's a little 1 here. Would you agree? What if we bring this above the fraction bar? We get 2 what? To the negative 1 x.
But you can't have negative exponent.
But we're trying to solve. We're trying to solve here. Okay? Do you guys see that? That this is like super important for moving on. So if you don't see it, we need to keep talking.
Do you do this with every fraction?
Yes. Well, so the key is we need to get the same bases, right? When it's in a fraction, it's not the right base for us. But if we bring that 2, because we know that we could get 4 written as a base of 2 squared, we can also get that 2 to be a whole number base if we bring it above the fraction bar with a negative exponent, right? So now what can we do? Now what should we do here?
Put the X into that.
Right. Let's multiply. 2 to the negative x equals 2 squared. Now can I solve?
No.
Yeah, because we have the same base.
You can't have a negative exponent.
We're not done solving the problem. You can't leave an answer with a negative exponent, but we aren't done solving the problem. We're trying to solve for x. So at this point, we're not worried about negative exponents because we're not done. You're not giving me an answer that has a negative exponent. We're trying to solve. Does that make sense?
Yeah.
So you can you can sort of mess with the rules a little bit while we're solving. So if we say negative x equals 2, and then we'll divide both sides by a negative 1, x is equal to negative 2. Okay, first of all, what do you notice? What's something that you notice off the bat that you think you should take care of?
The number 4.
Okay. The number 4, so let's start by looking at these numbers. We've got 4 and we've got 64. Could we get these to have the same base?
Yes.
What would it be?
8.
4 or 6.
Wait, no.
No.
8 to the second, because that would be 64, and then you could have
4 to the plus. I don't know.
no. That would work.
I think it would be 4.
Okay, let's try 4.
Wait, they both go into 16. They both go into 16.
No, but 4 to the
Oh, no,
3rd
they
is
don't.
6.
That's Kate. Listen to Walter. He's got it. Walter's got it. You guys, what is 64 as a power?
8
8 squared. Is that going to help us? No. It's 4 to the 3rd. Is that going to help us?
Yes.
Yes. So let's do, right, bring this down. 4 to the x plus 1 is equal to 1 over, let's rewrite 64 as 4 to the 3rd. Now, we don't want it in a fraction. We want to have a base of 4. So what should we do with this denominator to get it to, yes, bring it above the fraction bar, which will make what happen?
It's a negative.
Okay.
But why? Why?
What do you mean why?
Why would we bring it over?
Because we want it to be a base of 4. We don't want it to be part of a fraction. We want to have a whole number 4 as a base so that this is 4, this is 4.
Got it.
Good. Now the bases are the same. We can solve. All right, x plus 1 equals negative 3. Good. Subtract 1 on both sides. X equals negative 4.
Oh, you got 1 minute.
Aw, 1 minute. I'm going to stop you right there and let you just ponder this.